Hi guys, welcome to FEMA Academy. In this video, we are trying to learn electric potential difference or voltage. Electric potential difference or voltage. And again, as I said earlier in the previous videos, we are looking into voltage from the perspective of circuit theory. Before going into voltage, we must understand this term, that is circuit element. A circuit element is a mathematical model of a two-terminal electrical device. So please notice that it is a mathematical model. It's a mathematical model of a two-terminal electrical device. So these words are important. It is a mathematical model of a two-terminal electrical device. It can be completely characterized by its voltage-current relationship. So it can be using a mathematical equations with current and voltage, we can completely explain its behavior, and it cannot be subdivided. It cannot be subdivided into other two-terminal devices. So it is the last element. It cannot be subdivided. So that is a circuit element. So 3 points. First point is a mathematical model, and it is a two-terminal electrical device. It can be completely characterized by its voltage-current relationship, and it cannot be subdivided further into two-terminal device. So I have shown a diagram here. So it's a black box, and we don't know which element it is. It can be anything. It can be a resistor, it can be a capacitor, it can be an inductor. But let us represent a general circuit element here using this box. And as shown in the figure, it has two terminals, terminal A and terminal B. So this is the representation of a circuit element. Now we are trying to pass a current from terminal A to the circuit element and then to the circuit to the terminal B. Please notice, we are trying to pass a current from terminal A through the circuit element and to the terminal B. And when we do that, if we need to utilize some energy to push the charges from one terminal to another. So we know that the current is nothing but flow of charges. And when we try to push these charges from terminal A to terminal B through the circuit element, and if we need to use some energy for that, then we can say that there exists a electrical potential difference or voltage. So you are familiar with this word voltage. So here we are trying to understand what is meant by that across the two terminals. So if we want to use some energy to push charges from terminal A to terminal B through this circuit element, then we say that there exists an electrical potential difference or voltage across the two terminals of this circuit element. So I have shown it here using the letter V of T, and you can see here it is marked plus and minus. The top terminal is marked plus and the bottom terminal is marked minus. So in other words, we can say that the measure of work required to move charge through a circuit element is equal to the voltage across its terminals. How much work is required? How much work is required to move charges through this circuit element? That is the voltage across the terminals of that circuit element. So the unit of voltage is volt. You are familiar with that. The unit of voltage is volt, and it is represented using capital V if it is a constant voltage and small letter v if it is an instantaneous or continuously varying voltage. Now we have a doubt, if there is no current passing through the circuit element, then is there any voltage? Yes, a voltage can exist between a pair of electrical terminals without flow of current. So the best example is a battery. So you all are familiar with the batteries like this. So AAA battery, AA batteries, you have seen these kind of batteries, and this is the positive terminal and this is negative terminal. So let us say this battery is 1.5 volt. Even though there is no current flow through this battery, since there is no external connection, we should say that there exists a voltage of 1.5 across this terminal. So it is not necessary that there should be current flow for a potential difference to appear across the two terminals. So the best example is battery. So now the other question is what happens to the energy we utilize to push charges from one terminal to other. We have said that we are trying, this is a circuit element and this is terminal A and this is terminal B, and we are applying some current I, and what happens to the energy? We said that we need to do some work, or we need to use some energy to push the charges from terminal A to terminal B through this circuit element. So what happens to this energy we utilize to push the charges? So the answer lies at the working of the electrical equipments or electrical terminal device. It must appear somewhere else in the circuit or in the circuit element itself. It must appear somewhere in the circuit or in the circuit element itself. So the best example is bulb. For example, let us say that our two terminal device is a bulb. So this is a symbol of a bulb, and this is terminal A and this is terminal B. So we are applying some voltage across this terminal and we are trying to push charges from terminal A to terminal B through this bulb. So suddenly we can see that the bulb will glow. So the energy we utilize to push the charges from terminal A to terminal B is converted to light energy in the case of bulb. So this is how we represent the voltage. There should be two terminals, and the top terminal is always denoted by plus sign and the bottom terminal is always denoted using the negative sign, and we will write V of t or the voltage, for example 5 volt or minus 10 volt across these two terminals. So this is how we are representing in this particular representation we can see that terminal A is positive with respect to the terminal B. So that is why we have marked here positive and marked here negative. So this is about the electric potential difference or voltage if we look from the perspective of circuit theory. I hope it is clear. Thank you for watching.